Okay, so PS 10 is out and due at the end of the week. PS 11, remember, you will be modifying PS 10 by having it use a database, real database, which we'll be talking about this week. Any questions or problems about that or anything else? Yeah.
What's data contracts?
Data contracts. So when one of your service methods, one of your endpoint methods returns an object, it's serialized into either JSON or XML, depending on what was requested. And you can annotate. So if you're turning class foo, you can annotate foo as a data contract. And then if you do that, you can annotate some of the methods with other annotations that customize to some extent how it's serialized. And the only use case that I gave you for it is if you want to prevent a property that holds a default value from being serialized, you use those annotations. Otherwise, there's no need to use them. So the place to use that is the method that returns the status. All right, the status, there's a lot of detail in the status, but if the user requests a brief status, you don't want all that detail to come back. And you can suppress that detail by storing default values, i.e. null, zero, false, whatever, in the properties that you don't want to have serialized. And then annotate the property such that default values aren't emitted. And that's what that's for. Yes?
On your examples for your to-do list server, there were just a ton of different files and things. And all we're doing is writing a controller, is that correct?
Yeah. What you'll have to contribute is you have to write a controller. You also have to declare the types that the endpoints take as parameters or return as results. So in terms of the
what smaller classes?
Right, and you'll in the to-do list server you'll find the to-do controller in the controller folder, and you'll find those other classes in the models folder.
Yeah, but there's a ton of other. There were other.
Oh yeah. Well, you just go generate one of those, API, web API, ASP.NET, and you get all that stuff.
I didn't get all of it.
You get a lot of stuff. Yep. Yes?
Is there a certain place where we implement API.html in the Boggle service pieces?
Oh, okay. You don't have to do anything with API.html if you don't want to. Right. If you're interested, so when you run my Boggle service, you click on API, and then it takes you to the API the system generated, and there's a link there to the detailed API, which is my file. There's a .html file among all those that are generated when the project is created. There's one where you can go add. You could add that link if you wanted to, but don't worry about it. Any other questions? Okay, now, if this were last year, we would be like knee-deep in problems right now. All kinds of weird stuff would be happening with the old style of API project I used last year. So this is very encouraging. So far it's gone incredibly smoothly compared to other years. So that's good. Okay, last time we talked about, let me check the video here a second. We were talking about building relational databases. And just to remind you, let me go back to here. This is what we came up with. So we designed our database to consist of 5 tables to keep track of information about a library. So we have a table that keeps track of patrons and their card numbers. We have a table that keeps track of the books in the library, books, authors, ISBN numbers, phone numbers associated with library card numbers, keep track of what copies of books are checked out, and we have a mapping from these kind of IDs to these serial numbers over here. So that contains about a bunch of information about our library. In the lab tomorrow, what you'll be doing is I'm going to show you how to create a database, add a database to your project, and then how to go into that, once you've created the database, adding tables like this to the project, to the database. So basically how to create the schema in the database, and how to set what the primary keys are and the foreign keys and so on. So essentially take you through all the steps of creating a database, and furthermore, it's a database that's intended for you to use in PS11. So it's really the first step of PS11 is to complete tomorrow's lab. So you need to take that lab seriously. You need to do it eventually, whether you go tomorrow or not. So you'll be working with that. Once you have a database built, once you have all the tables declared, then we run into the problem of how do you get data in and how do you get data out? And that comes down to understanding SQL or SQL, depending on how you first heard it pronounced. So that stands for Structured Query Language, and it's sort of a standardized language. There are different dialects for different database systems, but it's 95% or 99% the same across platforms. It's a programming language independent way of manipulating relational database systems. So there's sort of two steps to learning how to use SQL. First step is just learn how to write queries. Second step is, once you know how to use it, how to embed those queries into programs. So what we'll do today is we will just experiment directly with SQL statements. And then next time I'll show you how to use it from C#. So two different things. So we're pretty language independent today. In past iterations of this class, I've had students use MySQL or MySQL, which is a popular open source database system. And it's networked, so it runs on a server and then you connect to it over the network. Rather than use that, since Visual Studio comes packaged with support for databases, we'll just use the system that's built into that's available from Visual Studio. And next week, in 2 weeks, after you finish PS11, you'll see how to push it all up to the web, to the cloud, so that your database will actually be deployed on a database server on the cloud, and the rest of your code will be deployed on a web server, and they'll communicate. So the general model is you can have your web server running here on one computer, your database is running here on a different computer, and they communicate over the network. For PS11, though, it'll all be inside Visual Studio, so there's no network involved, but it's really no big deal. You change one line, and suddenly it's communicating over the network. Okay, so I have slides here that show various things you can do with database, but I'm not going to. I'll leave them here so we can refer to them later, or when I get stuck or something, forget something. But instead, what I want to do is just use Visual Studio, show you how to use what's on those slides directly in Visual Studio. So what I have, let me turn on the magnification here. I think that's what I wanted. Okay, so I'm sort of magnifying the entire Visual Studio window here, so you have hope of seeing what's going on. All I did was I created over there in a new solution called LibraryDB, and this is in the examples repo, a new, console project, I think. And then I added to it just by right-clicking and saying add a database. And that's what you'll be doing in the lab tomorrow. You'll take a project and add a database to it, and then you'll see how to set up the tables and so forth. And I did it, you'll be doing it for a Boggle database. I did it for the library database I just showed you. So let me make it a little darker. When you have a database and you double click on it, so over here you'll see library.mdf is what this is. And you double click on it and you get to view it in the Server Explorer, which pops up over here. And you can see under Server Explorer I have library.mdf. right here. And under it, I have tables. So there's those 5 tables we talked about. If I double click on a table, it shows up over here. So for example, this is showing me right now what table is this? Catalog. So there's a database, there's a table called catalog, and it has columns, serial number and book ID, both of which are ints. And then you see a little key looking thing right there next to serial number. So what does that mean? That's the primary key. And you'll be creating tables like this by going and clicking and pulling down menus and such. This little snippet of SQL right here is the actual. If you wanted to recreate this table somewhere else, you just run this. So essentially, what you'll be doing tomorrow is indirectly creating this code right here that created the table, but you'll be doing it graphically. All right, so you've got these tables declared. They all have different properties. So let's play around with them. So what I'm going to do is I'm going to go to tables. I'm going to right click. I'm going to say new query, and it will bring up a tab here, or it should, where I can enter a database query. So what we do is we pick one of these tables. So let me show you the simplest thing to do to a table. You can say select every row from some table, let's say patrons. Okay, so there's our, that's a query. So a lot of the queries we'll look at begin with select. And when you have a select statement, you're asking it you tell it what rows you want to see and what table you want to see it from. So that star means show me all the rows and all the columns from patrons. So let's run it. I click on that little thing there, and it runs it, and down here you see that it contains the 4 patrons that I showed you last time. So I've got Joe, Ann, Ben, and Dan, and then we got card numbers 1, 2, 3, 4. So there's your first SQL query. All right, let's try something else. Suppose you wanted just the names of the patrons. You didn't care about the card number. So the star says, give me all the columns. If you can instead say, just give me the name column. So there's a different query. Select, I'm asking for all the rows, but I just want to see one column. So if I run that, I get back a different table. It just has one column, name. Now I could ask for both columns. I could say name column, comma, ID. And it doesn't like it, likes that. I run it. It doesn't like that. Okay. I've forgotten what the column. You remember what the column was called? Card number. Okay. So if I say name card number and run it, then I get it back that way. Name comes first, card number comes second. So you think of the database as a collection of tables, and when you interact with the database, what you get back is other tables, essentially. These queries that I'm showing you, when you write a program to access a database, you're going to be putting these queries will appear verbatim in your code. So it's not like I'm going to give you some library that lets you code these up in C#. I'll give you a library that lets you express things like that as a string. So you give it the quoted query you want to run, and it gets run for you. Okay? What else might we want to do besides just look at some of the columns? Okay, maybe we don't want to see all the rows. Maybe I only care about the row where name equals Ann. Okay, so that first way, instead of doing the star where you list just the columns you care about, that's called a projection in formal, if you study you take a database class, that would be called a projection. And what's coming up next is called a selection, where we're asking for some of the rows. So this says, give me all the columns, but only the rows where Ann is on the row. So let's run, no, don't do that. Run here. And there we just get the one row back from the table. Or maybe we want to do something different. Maybe we just want to see the card numbers that are greater than 2. And we get those back. So you put Boolean expressions there. Yeah?
Can you use regex in selections?
He's asking, can you use regex to express these conditions? I'm not sure. I've never used it, but that doesn't mean you can't. Now, what you'll find is there's sort of 2 approaches you can take. You can become proficient at SQL. And so you could do something like this. You could say, okay, I want some of the rows out of, or let me put it this way. You could become barely literate. Let's start with that. Barely literate at SQL. And all you know is how to ask for the whole table back. And so you run your query like that. And then once you get it back, you know, when you call this a C# program, now you've got this data. Now you could write a loop that went through and selected out what you wanted, right? You could write a program that looped through this data and looked at the card number and just pulled out the ones that were greater than 2. Or you could become more proficient at SQL and let the database server do that for you. It's sort of a trade-off, right? You're already good at C#. So the temptation is to let the, do a minimum amount of SQL and do a lot of computing over here. But what's the disadvantage of that? Yeah?
SQL is a language-independent, database thing. And so if you go to another language, you might like being able to rely on the database server.
Yeah, the nice thing is, you write if you can write a complicated query that does a lot of stuff inside SQL, that same query is going to work in a different language. On the other hand, if you write a minimal one and do all your work in C#, it's harder to port. Okay, the other thing is, you're talking over a network, so you don't necessarily want to get the whole table sent over the network just so you can throw most of it away. Ask the server to throw most of it away. Yeah?
Would it be faster to do a query in SQL than to get all the information and do it in C#?
Okay, he's asking, would it be faster to do it all in SQL rather than doing it in C#? Yes, it would be. Everything else being equal, I think it would be faster to do it in SQL because that's really highly tuned. You know, researchers have spent decades, as I said, making that stuff work efficiently. But sometimes it comes down to which machine do you want to load. Anything that you do in SQL is going to happen on the database server. Anything that you do outside of SQL is going to happen on your web server. So if your database server is being slammed, maybe you want to do more on this side. There's also a way we want to look at. It's called stored procedures, where essentially you write some code and store it in the database. And then instead of issuing a query, you just tell the database to run that stored procedure for you and get the data back. That saves having to transmit the query and having the query has to be compiled when it gets over there. We'll just stick to the basics for now. Yeah?
So at Microsoft's dialect of SQL is a semicolon at the end of the line option, or is it a syntax error?
Okay. So we're using T-SQL, which is your SQL T. Does that say T-SQL? Yeah, it looks like the semicolon is optional. Okay. So far, pretty simple. What might you want to do besides look at all the contents of a table or some of its columns or some of its rows? Yeah, back there.
Use the value that you get to look it up into a different table.
Okay, we might want to get information from 2 tables and combine it. So let's look at our okay, this right here. Let's see what we might want to do. Let's look up phone numbers. Okay, so we got one table that associates card numbers and names, another one that maps card numbers to phones. And we might want to say, what's Joe's phone number? And we can't get that information from one table. So this, when you got to look at more than one table to get something, what you're typically doing is called a join. There are various kinds of joins, but they refer to different ways of combining 2 or more tables in order to get composite data out. So let's do a join on patrons and phones, or a join-like thing. Okay. And these queries that I'm doing are going to disappear into the ether, but they're all, or things like them are replicated in the slides, so you can look at them later. So let's try this. So patrons and phones. Okay, now what I've done there is not what you would call a join. It's called a cross product, and it's not very useful, but it's where I like to start when I'm explaining what a join is. So what I'm asking for is select everything from both tables. So let's run this and see what we get out. Let me enlarge this. Oh, this. Now, you remember the one table had 4 entries, 4 people. The other one, I think, had 5 or 6 phone numbers in them. Some of the patrons had more than one phone number. And what came out was 20 rows in this table. And you notice there's one called card num, another called name, another called card num, another named phone. So what happened here? This is called a cross product, if that helps. You ever heard of a cross product? Yeah.
It basically took everything that started at Joe and then put it together with everything in phones, then went to Ann, put it together with everything in phones, and just went through.
Exactly. It took every row from the first table and paired it with every row from the second table. So you see the first row is Joe 1, or 1 Joe. So that they got that from the first table. Then there were 4 rows in the next table. So 5 rows. This 1, 2, 3, 4, 4. Those were the 5 rows from the second table. So it married up 1 Joe with each of those rows. And did the same thing for 2 Ann, 3 Dan, 4 Dan. And so 4 times 5 is 20. That's why there's 20 rows. Just pairwise matching. Now, that's not very interesting because who cares that 2 Ann and 4, 9999999 are on the same row? Ann has nothing to do with that phone number. Which rows in this table do we care about? Where the card numbers are the same. Those are the interesting rows. So like right here, 2 Ann, 2, all 6s. Ann's number was that. So the rows we care about are where these card numbers match up. So rather than do what I just did, we need to refine it a little bit. We need to say, essentially what we'd like to say is where card num equals card num. Which card num are we talking about? There's 2 columns called card num, so we need to be specific. I want patrons.cardnum to equal phones.cardnum. Okay, so I'm saying select every row from the cross product, but only give me the ones where the card numbers agree. And so when I run this, how many rows will I get this way? Turns out to be 5 because Dan has 2 numbers. So it'll be a subset of the rows we saw before. So I run it, and there you go. You have 1 Joe 1 phone number, 2 Ann 2 phone number, 3 Ben 3, and then 2 rows for Dan. Yeah?
Why don't you need to use the Boolean double equals on the card number?
Why don't you use the Boolean double equal on card num? Because
That's SQL.
this is SQL. It's not C#, and they use a single equals.
So it's not necessarily a Boolean statement. It's
Oh, it's definitely a Boolean statement. Don't read that as assignment. There's no assignment. This means, this single equals means the same thing as a double equals in C#. It's equality. Okay? So that's good. It got us out the information we needed, or at least some of the information we needed. Now, you might look, this wasn't too bad because we were taking a 4-column table and a 5-column table and doing the cross product and pulling out the rows we cared about. But what if it was like a 5,000 line table and a 6,000 line table? Now instead of 20 things in the cross product, we're talking about 20 million things in the cross product. Okay? But we only care about like 6,000 of them. That seems wasteful, doesn't it? To ask it to compute this massive thing and throw most of the rows away. Yeah?
Slight aside, what if you're like the database person who has to manage if someone tries to query your server? to do a cross product that big.
Okay. Well, okay, what if you are, okay, you're,
How do you prevent someone from
Okay.
bogging down your server?
okay. So he's asking, this sounds bad, it would clog down the server. But the answer is it won't. Because we can look at this query and say, okay, abstractly what I'm asking is to compute a cross product and then just keep the rows where the columns agree, or just keep the rows where the card numbers agree. But the people that implemented your database, they don't run it that way. They know that if they run it that way, if they actually create the cross product, they're going to bog down the server. So they're just smarter about it, right? So they have some algorithm that efficiently takes the first row and finds the one it matches to over here and puts it in the result set. It doesn't build this massive thing and throw most of them away. It just builds the thing it wants. So this is a kind of declarative programming. You're describing the answer you want, but don't for a minute think you're describing how the server will compute it. Okay? It's not going to compute it the easiest way, the first way that jumps into your mind. Decades have gone on to figure out how to do queries like this efficiently. So we're sort of insulated from those details. Okay, any other questions about this? So there are, this is one way to do a join. There are actually some special join operators. There's different forms of join, left joins and inner joins and such. It's possible you might need one of those at some point, but for the time being, if you need to get stuff from two tables, or actually you can join more than two tables, what you want to do is just list the tables you're trying to combine, and then over in the where part, you got to have something. Typically, there's columns in common in the two tables, and you need to say something like they need to agree with each other. Now, what if we weren't interested in, we just wanted Ann's phone number? What query would we write to just to get Ann's phone number out? Right? If you want to restrict the rows you see, what do? What's that? Put more requirements after the where. So we'll say, space over here, so and before you ask me, you can't put double ampersand. That's C# and Java and a dozen other programming languages. You actually spell out the word and in SQL. And we want to have name equal to and, included in single quotes for whatever reason. Okay, so if I run this query, what am I going to get? Okay, I just get back the one row. Now this seems, if you're taking the view that what you're describing is how to compute the answer, this is a terrible way to compute the answer. To create this massive table and then throw all but one row away. But again, the query analyzer that runs in the database system is smart enough to look at this and figure out how to do it efficiently. You just take advantage of that. Just trust the database server to get it right. Now, this is more detail still than I want. I just wanted Ann's phone number. I know her name. I don't care about her card number. So how could I just get the phone number? Yeah? Well, it wouldn't have to be after that. It would be right here is where we say what columns we want to get out. And instead of asking for all of them, we'll just ask for phone. So now our query is like that, and we do we execute the query, and the database sends that back. So it just depends how much work you want to offload onto the database system and how much you want to do inside C# to get the answer. Yeah.
So if we're working with multiple tables and their column names are all unique, we don't need to specify which table we want that column from.
Exactly. The only reason I had to say patrons.card number is because there's a card number in both tables.
Got it.
So I've got to say which one in there.
You can still say like phones.phone, right?
You can still say it, right? I could say select phones.phone. And I could also do something like this. I think it works like as. Right, I'm going to say that, see if it works. So that as is saying when you send the table back, instead of calling the column phone, call it Ann's phone. So you can do that sort of trick too. Okay? So let's think ahead to next week when you're working on PS11. You're going to need, you're going to have those endpoints to write. And you'll have the databases designed for you. And you'll need to do something like get all the words that were played in a game by this player, or something like that. What will you do to put the right query into your program? I know I'm going way ahead because I've got to show you how to embed these things into C#. But at some point, you'll know how to, you'll learn how to write queries, learn how to embed them in C#. So what will be sort of your work cycle? When you're writing an endpoint method and you realize, oh, I need a query that gets this information out of the database for me, or puts this information in the database for me. Yeah?
Let's say start simple and then build it up.
Okay, so you can do it the way I did it here. You start simple and build it up. But the point is, you don't want to write a query, type it into your C# program, and run the C# program and debug that way. Okay? You want to use this interface here. You want to pick the query you want to run, play around with it, get it exactly right, and then copy it and paste it in your program. This is the place to debug queries. Got enough stuff can go wrong with your C# program, but at least you can get the query working right here. Okay, so what else might we want to do with our, yeah?
I want to know how many phone numbers get stored.
Okay, we want to count how many phone numbers are stored. Okay, so there's a way to do that, and I never can remember when anyone asked that, but fortunately it's on the slide. So let's look at the slide here. Let me turn off the magnification for a minute. So let's see what I got here on the slides. So I show you how to select. There I'm selecting title and author separately. There I'm showing you how to, this is all titles between R and SUS. So that's just another select. This was the cross product that I showed you. There's a select I showed you that's doing the join. There's something similar to what we did where we're just selecting. I only asked for 3 columns instead of all of them. There's one I didn't show you. Look at that one for a second. What's that doing differently?
Just order them by name.
Yeah, we're ordering by name. So we get a table that has card number, name, and phone, and we're asking the server to sort it for us in increasing order of name, which it does here. So you can see the names are in alphabetical order. So we're offloading the problem of sorting to the server. Why is name in single quotes here? Unlike phones and patrons and card name and card number, rather, and so forth. You might ask. That's a reasonable question. Anyone got any guess as to why?
Is it not a key? Is that what?
It's what?
Is it because it's not a key?
No, it's not that it's not a key. It's just it's. Who's got another guess? Yeah.
Is it because you have to specify exactly what column you want?
No, it's nothing to do. It's just name has I think a reserved meaning in SQL.
Is it making it so it's a string, like it knows it's a string?
No, it's just that the name turns out to be a bad choice for a column because name is a keyword in SQL.
Oh.
Okay, and so I made this decision a long time ago, and I've been too lazy to change things, and so I have to explain why I put name in quotes. Okay, so don't make that mistake. Okay, so that puts things in alphabetical order. So here, how many phones does each patron have? So this is just hinting at the power that SQL gives you. Okay? This is just begins to show you the kinds of things you can ask for. I'm not pretending to teach you everything or most. I'm teaching you a good subset that'll work for your assignment. So let's look at what's different here. We're selecting, first of all, basically we're doing a join. So we're selecting from the two tables, phones and patrons, where the card numbers agree. We're sorting by name, but we are asking, here is, let me get this. Up here we ask for a card number column, a name column, and a table where the phones are counted, okay? So count of phone. So what shows up is, in each row is going to be the number of phones that go with the data earlier in the row. So like right here, to Ann has one number, so you see 1. The combination of 3 and Ben corresponds to 1 number. The combination of 4 and Dan corresponds to 2 numbers. And then you have this group by. So if you put count up here to count the phone numbers, you have to say, what are you counting? And essentially you're saying, I'm counting card number name combinations. So every unique card number name combination gets its own row, and you get the number of phones right there. Okay, so that's possible. You know, when I try really hard and I'm writing some queries, I don't do a lot of this. Sometimes I'll bear down and try to write a query that does exactly what I want, and sometimes I'll give up and get it close, and then fix it up when I get the data back on the C# side or the Java side. Okay, yeah.
What was group by again for you?
Okay, so up at the top, so if you put count up there, you have to put group by down here.
Okay.
It's just group by says what you're counting. So suppose we didn't have this column right here of numbers. You'd basically be asking how many rows are going to contain how many rows in the result would contain a given phone number, or a card number name combination. Instead of displaying both of those, just display the count. It's pretty specialized, but there's things you can do. You can write nested queries where you select from some tables based on the result of selecting from other tables. And it gets pretty involved. This is where you can rename a column. I showed you that before, the as. So now you see phone count right there as a column. And so that shows you pretty close to all, I think, pretty close to all you need to know to do PS11 in terms of extracting information from the table. But what's left is how do you get information from the table in the first place? Because the tables are created, they're empty. So there are also aspects of SQL that let you put stuff into the table. So let's take a break, and then we'll look at how you put data into tables.
Pulled it off of GitHub and I was trying to follow along, but it says that library.mdf doesn't exist. Like I tried to click on
I
it,
must have not.
and if you go over to
It's not in there. Okay, that's a good point. So what happens is that my .gitignore file is ignoring MDF files.
oh no.
But that's good because I need to show everybody that anyway.
All right, cool.
There's something wrong with the pseudo.
No.
When I was playing with the Boggle server, I found an exploit where it doesn't check for
Okay, an interesting conversation at the break. So it was from a student who was trying to follow on the lecture with my example. So he went and pulled down the library DB solution from, I guess he pulled down update to my examples repo, and then went to this thing I was doing and found out the database isn't in there. Right? The database is obviously here, and right before class I pushed it all up, and then he pulled it all down, but the library database, the actual library.mdf file, which is sitting over here, library.mdf, there are two files actually, library.mdf and library_log.ldf. Those two files weren't there for him to use. So who knows what went wrong? I knew immediately what went wrong. Yeah?
Get ignored.
Right. He said get ignore. So there is a file called .getignore that you may not have noticed before, but if we go and look in your solution here, folder, so we're opening File Explorer, and I go up to my examples repo, and my examples repo contains a file that, since it starts with a dot, it's not showing me which is which. I'll just open this one. I'm going to open it with, one of these is .getignore. I don't want to open it, I guess I've got no choice but to open it in Visual Studio. I wanted to open it in here it is. Okay, so what this does is, if you don't have a .getignore file, every time you push a project up, it takes every file that's contained in that solution folder, including the .exe files, the files that you get by compiling. And that's a waste of space, because, and not to mention it would make merging impossible, because you can always recompile later. So we just want the source to go up. So this file tells what file types this says files built by Visual Studio. It's essentially saying what files aren't sent up when you commit a project. So it's very important, and this is in the instructions for PS, or I guess it will be in the instructions for PS11. Be sure you adjust your .getignore file so that it doesn't ignore the databases, because otherwise you'll submit your project for us to grade and it will come without the database. So what I got to find is .mdf, which is right there, and I'm going to comment it out by putting a hash in front, and LDF I'm going to comment out, and I don't know what NDF is either, but it's there, so I will comment it out and save it. So now if I go and go back into Visual Studio and try to, let me go to Team Explorer and let me do a look at what has changed, and you'll see that what has changed, it's over here. Now it's saying there's a .mdf and LDF files that didn't exist before that do now. So so from now on, whenever I create a commit, it will actually I'll do this later. It wants me to save something I don't want to save. It'll actually send the database up with the rest of the project. So be sure to do that when you get into databases, like tomorrow. Go into your .getignore file, which is sitting at the top level of your repo, and comment out the LDF and MDF entries so that your databases are actually committed. Okay. All right, so back to where I was here. So now we've got the problem of how do you get data into a table? So typically, when you get data into tables, it's just done one table at a time. It's not done like a select works on multiple tables, that gathers data from multiple tables. Typically, when we're changing tables, we're just changing one at a time. And this is an example of how to do it. So we're saying insert into the patrons table, and then in parentheses we put the names of columns we're trying to give values for, and then we put values, and in parentheses we give the corresponding value for it. So we're asking the system to create a row called, not a row, we create a new row that has Marley as the name. Now, does that raise a red flag? What's in the row of a patrons table? Card number as well. So how can we create a row that contains the name of the patron, Marley, but not the card number to use with Marley? Yeah?
Could you set it to auto increment?
Right. When I defined the card number in the database, when I created the schema, I specified that card numbers were to be auto-incremented, or to be generated. And so I can just insert a row and not specify the card number, and it just picks the next one and uses it. So this will, if I were to run this on the table that I just showed you, it would add Marley as a 5th row in the patrons table with card number 5. Okay? So that's an insert. Add to a table that way. Now, an insert can fail. And it could fail if you, let's say I did an insert and I gave a card number that already existed, like 5, like 4. It would fail because it violates the constraint that card numbers are supposed to be unique. But anyway, this one would succeed. And it tells you, after it runs, how many rows were affected. That's an insert. This is an update operation. So this says, all right, go into the patrons table, and everywhere you see Marley, replace it with Bungie. Okay, so that's updating existing rows. Now, some database systems are configured where they will not let you do updates and deletes, especially deletes, unless you have a primary key after that where right there. Because, you could say set name to Bungie where true, for example, or just leave off the where. If you just said set name equals Bungie and put no where, what do you think would happen? Every single name would change to Bungie. Okay, so it's kind of a dangerous thing to do. And that's why some systems will at least make sure you really want to do that when you don't qualify the change with something having to do with a primary key. So that's an update. So let's think about your Boggle servers. Can you imagine having to insert into a table? What would be an example? Yeah.
Be a new user.
Okay, someone registers as a new user. You probably have a table that keeps track of users. So you'd have to add that person to a table. Yeah.
Words played.
Okay, when a word is played, there'll probably be a table that keeps track of what words have been played. And you need to add it to the table. So yeah, insert. What about update? Yeah.
Update the score.
Okay, maybe if there's a table that stores the current score of the game, you might have to go in that table and update the score. But I think my schema doesn't store the score. It just is designed so that when you need to know the score, you just compute it from a list of words. Do you have another item?
Time left.
Okay, time left. Well, I'm telling you, my database doesn't store time left because you'd have to update that constantly. You just store the time the game started and the time limit and compute the time left. Yeah?
Would it be where, with the game, it would update the player names that are in that certain game?
Okay, so that's a good example. So the way my design works is a game has 2 players and a status, but sometimes a game only has 1 player. So the pending game and the pending game only will have 1 player or 0 players. And as players join the pending game, you'll have to add a player into that row. You have to do an update. So yeah, you may need to use an update. Delete a row from a table. I don't think you'll need to use a delete. I can't think, you can't quit, right? You can't unregister as a user. You can't unplay a word. Yeah?
Deleting a pending player.
Can what?
Deleting a pending player from the game.
Well, you can to remove a pending player from a game, what you do is update the row, take them out. I guess you could delete the pending player, the pending game row, and then add a new row in. Anyway, that's how you delete. This one's really bad if you leave off the where. What would happen if you said delete from patrons? End of story.
The table's gone.
Whole table's gone. Now, I was thinking about this last time I was talking about databases, and I said they have this property that once you make a change, it's there forever. Okay?
You can't undo anything.
But I realized what that sounded like was that it's like a version control system. That's not what I meant. What I meant, if you make a change and don't do anything to change the change, it's not lost, even if the system crashes. But database is not a version control system. If you make a change and then undo the change, you don't have, it's gone. You don't have the original change. So don't think that you can mess up and delete every row from your table and recover from it. Right? Database isn't designed to go back to an older version. So delete from patrons would delete every row on the patrons table. So don't do that. Yeah.
So there's no way to do any version control whatsoever on a database.
I'm not going to say there's no way to do any version control. But yeah, I've had students that were shocked when I told them that it's, they can't go back to an earlier commit in the database. All right, so that's delete. Okay, so that's all there is to modifying the table. You insert, you do a lot of that. Update, you'll do a little bit of that, and delete, you might do a little bit of that. But insert's the workhorse there. Okay, so I'm about to segue into how to use this from C#. So let me pause here. It's a good place to pause and see if I can answer any questions about this. You're probably going to come to a point where there's going to be something you want to do in the database and maybe you can't quite figure out the right way to do the query, and that's a good thing to discuss on Piazza if there's some aspect of the language I failed to mention. Yeah?
I don't think this applies to this assignment, but what if you want to change like a column name permanently?
Okay, so what we're talking about, he's asking, what if you want to change a column name permanently? So you're not changing the data in the table, you're changing something about the table. So if we go back, you remember when I first started showing you Visual Studio, I showed you the T-SQL statement that was created, that would create the table from scratch. So basically, if you want to change the column, essentially what you would have to use is a query like that and tell the database server to change its table. But you can't, like any other server system, different users have different levels of privileges. Typically, you want to run a database system, when you use a remote database system, you're going to be essentially logging in, your program will log in as a user and change things about the database system. You want to give that user, that's the proxy for your program, to have the least privileges possible. And you certainly don't want to give it the privilege of being able to delete tables or rename columns and stuff like that. So why that? Why do you want to have your program to have the least powerful access to the program as possible? Yeah.
If you're a massive company and you don't want all of your data to be messed up by some rookie that you just hired, and you want to have these preventative measures.
Okay, right. So you want to make sure that only knowledgeable users are trusted users, but there's another reason. Yeah.
Pretty close to that, but even avoid accidents by those who are knowledgeable.
Avoid accidents, but also the data that goes in. If you have a program that is taking data from the user and that data gets stored into the table, that's a vector for hacking. Because you've got this program that's accessing a remote database. If you can hack your way into the program, you can start messing with the database, but you can only do the things that the program is allowed to do. So you want to keep that program to be as, have as few privileges as possible, so that if it's compromised, there's a limit to the damage that can be done. So typically, the front end of a service isn't going to provide a way to manipulate the table schema. Okay, any other questions about SQL? I've already said SQL more times today than in my life because I've always said SQL before, but I finally decided there are fewer syllables in SQL, so I've changed my stripes. Okay. So, All right, let me figure out what I've done here. Okay. All right, so we'll start talking about this today. I'm gonna talk about this today in the abstract. And next time we'll actually look at some code examples of how you use a database from C#. And the examples that we'll look at, there's a version of the to-do list server that uses databases instead of poor man's database to do its things, and that's in the repository, and it contains far more comments than code, deliberately, so that I can explain what's going on in there. So here are the basics for using from a database from a server. To use a database, you first have to open a connection to it. And so it would look something like that. You create the connection, you open the connection, and then you do your thing. And remember, we use the using construct so that when you exit the using block, the connection is closed automatically, no matter how you exit the block, whether you return or just execute beyond the end or throw an unhandled exception, the connection is closed down. Now, this is a very conservative way to use a database. Connections take some time to build and tear down. And building one and tearing it down, building it and tearing it down every time you make a connection is kind of wasteful. Nevertheless, I recommend you do it that way when you start. Another thing you could do is create a connection and just leave it open and keep reusing the connection throughout your program. The string right here is very important. That's called the connection string. And it is the URL, in a sense, of the server you want to use. So when you're doing your developing, that connection string will basically say, use localhost, use a database running on localhost. If you want to start using a different database server, say one on the cloud, only thing you have to change about the program is the connection string. You change the connection string and say, okay, use the database server at this URL up on the cloud, then this exact same code will work with it instead. And that's what you'll do when you deploy it to the cloud. You'll change the URL there. Now, that URL, when you're accessing on your local computer, there's no security involved. But when you're connecting to a remote server, you've got to give a username and a password to access it, and that's contained in that URL somewhere. So typically there are credentials in the connection string. There aren't any credentials here because, first of all, you can't see anything with the dots, but we're just using a local server, so no credentials necessary. So that's the first thing. You write code to create a connection. The next thing to know about besides connections are transactions. So a transaction is a unit of change. So typically, you're going to go into the database and you may make several changes to the database. You may say, do this insertion, do this update, do this deletion. And what you want to do is treat all three changes as a single unit, meaning either all three happen or none of the three happen. You don't want to get into a situation where you've made one change and the two they depend on haven't been made yet and the system crashes and your database is corrupted. So we use transactions to group operations into atomic units. So you can say, we say using again because it's a resource. We create a transaction, we start a transaction, we do stuff, and at the end of the transaction, you can either commit it or you can roll it back. If you roll it back, that just cancels it. It's like it never happened. If you commit it, that's what makes it show up. In the examples you'll see of mine, I don't bother rolling back. I just commit if I want to, and if I don't, then when the transaction ends, it'll be rolled back automatically. So if the transaction works as I expected, no unhandled exceptions, I hit the commit, everything is good. If something goes wrong, the data is bad, the input data from the user is bad or something, then I don't commit, and it's as if I did nothing to the database. What this gives you when you use transactions is atomicity and serializability. Atomicity, I just mentioned, it's an all or nothing thing. You'll never have a partial transaction that partially changed the database but didn't finish. That's a recipe for corrupting the database. So you got that. You also got serializability, because it won't be the case for you, but typically you're going to have, well, it could be the case for you because you're writing a service. You can have multiple connections made at the same time to the database, all trying to change the same table. And if everyone is doing it via transactions, then it's going to appear as if the transactions ran in some order. You won't be able to say, oh, it happened. You won't see these things. You won't see evidence that they're running in parallel. It'll look like it went bing, 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 bing. Now, there's a price you pay for this. The price you pay is transactions can fail sometimes because too many things are going on at the same time. So it tries to manage concurrent access with locks and being careful about the order in which it does things. But occasionally it may get stuck and say, there's no way forward, and the database decides to kill a transaction. So another one can finish. So it's possible that when you your transaction will fail by throwing an exception. Now, I just sort of let that happen, and in my example, I don't do anything about it. You can catch the exception. What would be a reasonable thing to do if you catch an exception and it says that the transaction failed because of some concurrency issue inside the database? Right, you just try again, and it'll probably work that time. So try it once or twice, and if it still doesn't work, you can display a message, oops, well, you're a service, so you wouldn't display a message. You'd send some code back that the attempt failed. So what you'll see is you'll have connections. Inside the connection, you'll start a transaction. Let me emphasize that you don't have to worry about this multiple thread issue at all. So you don't have to put any locks. Now, in PS10, you're putting a very draconian lock on every implementation of every endpoint to serialize them. So you can get rid of the locks, you can get rid of the synchronizing object, you just call the database and let it worry about concurrency control, because it's better at it than any of us can ever hope to be. Okay, connection, transaction started, and then inside the transaction you can start doing stuff. So here's some examples. We can, what we have to do is create a command, and what do you suppose goes in the argument right there to the SQL command constructor? What would go between those quotes? Yeah?
The SQL statement that we want to run.
Right. The stuff we were just doing in the query processor. So that you go to the query analyzer tool, you experiment, get your query just right, and you just paste it in between the quote marks. So if you're trying to do an insert, you put an insert command. If you're trying to get data out, you put a select command, or an update, or a delete, or whatever. That's what goes there. And then you run it in different ways. If it's a select statement, you run it this way. If it's a update, insert, delete, you run it as execute non-query. And sometimes when you do an insertion, you want to get back the auto-incremented key that was created, and you do this middle way that way. So 3 ways to run the command depending on what you're asking, what you expect to get back. And that's the stuff we were looking at before. All right, so we've got connection created, transaction started, then we issue commands. What's left? Yeah?
How do you defend against the SQL injection?
Okay, SQL injection. It's interesting. I've never heard that called SQL injection. So that's just odd. Anyway, yeah, we'll get to there. But what else do you have to know in terms of C# programming? Yeah?
Actually, that wasn't answering that question.
Okay.
Do you need to close the connection?
Well, you got to close the connection, but that happens because we're using the using. So when you exit the block, it's closed for you. Okay, so I've showed you how to issue a select command. What did I tell you? What was that? Yeah?
How to actually
Right. How do you get the data back? What form does the data come back in? How do you get the answers? So let's go on here. So first of all, let's issue a non-query. So it's reserving the word query for a select statement where you get data back. So execute non-query is you're doing an update, an insert, or a delete. And what you get back is an int, and it tells you how many rows were changed in the table. So you ask it to delete some rows. It tells you how many were deleted. So you can use that number that came back for whatever reason, to make sure something happened. Okay, so that's one thing. If you're doing an insert and you're depending on the system to generate the auto incremented key, that's how you do it. You do execute scalar, and what you get back is the key that was generated for you. So that'll be useful in some circumstances, like probably for the game ID in your Boggle game. It can be auto generated. And if what you got is a query, you execute it with execute reader, and what you get back is a SQL data reader object that you can use to extract the data. Okay, we will dive into exactly what you do with the reader in a second. So I'm throwing a lot of stuff at you. Remember, we'll revisit this next time and see it actually working in practice. So let's look at this example here. Suppose that you want to, you have obtained a task ID from a web form, and you want to make a delete statement. So suppose it's my task, task list server, and the user says delete task 5 for me. And so you've got to create a query to delete task 5. And so that query is going to be delete from tasks where task ID equals 5, right? And so you compose the query this way, and then you execute it like that. Okay, now let me ask you this question. What happens if instead of entering 5 in the form, so your user typed 5 into a form and hit submit, and we deleted task 5? What if they put that into the form?
Does it delete everything?
Okay, it does.
Because it's a true statement, right?
But what's the effect? What happens when this text is used as the task ID up there? What does the query become?
Task ID equals true.
It says delete from tasks where task ID equals 0 or 5 equals 5. So task ID equals 0 is probably going to be false, but 5 equals 5 is going to be true. So you're basically saying delete from tasks where task ID we're true. Okay? That's SQL injection, SQL injection, where your user is diabolical, learns something about your implementation, and figures out just the right thing to type here as data so that it gets, when it's pasted into the query, it corrupts the meaning of the query and does something awful, like delete the table. Okay? So this is it's a real rookie mistake to compose a query that way by appending strings. Don't do it, or you get your I won't say you get what you deserve, but you'll have trouble. Okay, it's so easy to avoid. There's no excuse for not avoiding it. So you don't want to compose your query like that. So this is a famous X-Casity cartoon. So this is mom, and she says, hi, or she's hearing, this is your son's school, we're having some computer trouble. And she says, oh dear, did he break something? And the school says, did you really name your son Robert, end quote, in parenthesis, semicolon, drop table students? Yes, little Bobby tables, we call them. And we've lost this year's student records. I hope you're happy. I hope you've learned to sanitize your database. Okay? Okay. So now that I've motivated the problem, let's talk about the solution. This is how you compose a query. You got to get input from the data, but you got to input from your user. And you've got to incorporate that input into the query very often, but do it this way. So you create a string that contains these placeholders where you want user data. So at task ID, in this case. Then, after we create the command, for each one of those main parameters up there, we say replace it with the user input. Okay? Now, and then you run the query. So how is this an improvement? Than just pasting in, yeah.
It will treat the entire thing as a string instead of trying to.
Yeah, essentially. So this add with value is smart enough that it looks at task ID, and if it's using any special characters like semicolons or end quotes or and any keywords, it sanitizes it. It basically quotes everything, escapes everything, so it no longer functions as the way the hacker intended. It just, the task ID becomes that literal string, and and garbage goes in the database as opposed to your database being garbage. Okay? Now, why not just do the sanitization yourself? You could take the task ID and look at it and sanitize it until it's inert and then stick it in the database. It's the same answer I always give for databases. Someone smarter than you, smarter than all of us, figured out how to do this, so trust them to have done it. So there are a couple variants of this idea where you let the C# code plug in the user data into the query. Be sure you're using one of those variants. Don't ever fall for the temptation of pasting them in yourself, because that's just you're leaving your database wide open. Okay? All right, so that is such an important point. I'll end on it. So we'll pick up with this next time. Just remember to always sanitize your inputs.